Welcome to my channel. Your tutor Mariam is here. It's the 18th video of Introductory Physics 1 and the 5th video that I'm going to talk about the vector, which is the third subject of Introductory Physics 1. In this video, I'm going to talk about the vector product and what is the scalar and dot product and how you can multiply two vectors together or a scalar with vector. If you are new to Introductory Physics 1 and like to learn more, hit the subscribe button and like for more. You ready? Let's get started. So the first thing is multiplying a vector by a scalar. So let's say I have a vector A, I want to make it longer. The way I can do this, I can multiply it by a number. Let's say I'm gonna make it twice longer. And then I can say is my vector gonna be multiplied by n, right? And then also I can make it shorter if I multiply this like half of the vector. Then I can have the shorter vector. Let me show you an example. For example, my m times a is gonna be, for example, 2 times vector a, and then at this point I have a longer vector, and for s is going to be a number times vector a, so I'm going to multiply by half of the vector, so it's going to be multiplied by a. And this is a way I can make a vector shorter or longer. Also, I can multiply two vectors together. And two vector can be multiple by dot or cross. The difference is like if I go with the dot, then a dot b gonna be vector a times vector b and cosine theta. And theta gonna be the angle between vector a and b. For example, I have a vector a here, and then this gonna be vector b. And is the theta gonna be the angle between vector a and b. However, for the cross product is gonna be vector a times vector b times sine theta. So instead of going with the cosine theta, we're gonna calculate it with the sine theta. There is a rule, you might be familiar with that. It's called commutative law, which it says a dot b is equal to b dot a. So it's like it doesn't matter, a come first or b come first. However, in terms of the cross product, we cannot say that. A cross b cannot be equal to b cross a. However, a cross b can be equal to negative b cross a. And this negative sign is all about the right-hand rules. Like if you go with b first, then the direction gonna be changed in terms of the right-hand rules, and that's why you have to consider the negative sign here. You might wonder how we can show the product of vector in terms of the unit vector. Let me show you. Let me start with the dot product. And let me write down the vector a and b in terms of the unit vector. Feel free to pause the video and do it by yourself. So for vector a, I'm gonna say my vector gonna be axi plus ayj, right? I'm gonna work with two dimensions. And for vector b, I have bxi plus byj, right? Again, I'm gonna emphasize that I'm working with two dimension or two coordinate here. Now my a dot b gonna be axi plus ayj dot, and then my b gonna be bxi plus byj. right? And then, as you remember from the previous video, this unit vector only can be multiplied with the same unit vector. So what I mean, ax only can be multiplied by bx, and ay only can multiply by by. So let me write it down. It's going to be ax times bx in x direction or I, and then it's going to be ay times by in j direction or y axis. But how about the cross product? Here I'm going to work with three coordinate. So let's say my a gonna be ax I plus ay j plus az in k direction, and my b gonna be bx I and then by j plus bz in k, right? And these are all vectors. Then what I usually do is for the product, I'm gonna go with the matrices. So let's write down the matrices for cross product of these two vectors. So I have I, j, k, as I'm working with 3-dimension or 3 coordinate. And then I have the first vector in the second row, so it's going to be ax, ay, az, and then for the second vector I'm going to write it down in the third row, so it's going to be bx, by, and then bz, right? And then for the first unit vector, which is I, I'm going to eliminate the first row and the first column. So then my matrix is going to be I. Now what I left here is like ay, az, by, bz, right? And then for the second one, which is j, what I'm gonna do, I'm gonna eliminate the first row again, but this time I'm gonna eliminate the second row, second column. So that means I have ax, az, bx, bz. And then for the last one, again, is gonna be the first row and then the second column. Now what I have is like ax, ay, bx, by. Now is like the answer gonna be sum of three determinant. So now I can say my I gonna be ay times bz minus az times by plus j gonna be ax, az times bx minus ax, bz, and the last one gonna be k, ax times by minus ay, bx. And then these times here, these are not a dot product, it's just a multiple. So don't be confused about this guy right here. This is just a normal product of two vector, not a dot product. And then this gonna be my final answer here. Sometimes the student try to simplify this, but be careful. You cannot simplify this as they have a different direction. So this guy right here is in the y-axis and this guy here is in the x-axis. Even if you go with the value, sometimes you have to calculate with the value and you try to simplify it and then add them together, subtract that. You cannot do that because they have a different direction. In the next video, I'm going to solve a couple of examples about this subject, and I'm hoping this video help you to understand the multiple vector, how you can multiple vector by a scalar or the other vector, and what is the difference between the cross and dot product. If you like my video, hit the like button and see you in the next video.